Hello everyone. Hello everyone. This is our project 2. Here in this presentation we are going to explain about the differences between the accuracy of different algorithms. We are from team 3. These are the machine learning algorithms that we are going to discuss in this presentation. One is the k-nearest algorithm, decision tree, and the SGD algorithm, random forest, and the SVM algorithm. Next. When it comes to the k-nearest neighbors algorithm, it is one of the simplest machine learning algorithms based on supervised learning technique. And this algorithm assumes the similarity between the new case data and available cases and put the new case into the category that is most similar to the available category. And this algorithm can be used for regression as well as for classification, but mostly it is used for the classification of the problems. And this is also called as the lazy learner algorithm. And when it comes to this algorithm, how it works, here we can see the picture before the KNN algorithm and after the KNN algorithm. And here we are selecting the K of the neighbors and then calculating the distance. And then when it comes to the decision tree algorithm, it is a non-parametric supervised learning algorithm for classification and regression tasks. It has a hierarchical tree structure consisting of a root node, branches, internal nodes, and a leaf node. These decision trees are used for classification and regression tasks, which is easy to understand. This algorithm uses conditional control statements and is parametric supervised learning. When it comes how it works, here we can see the root node, which is classifying into the decision node. And this decision node is further classified into the terminal node and the decision node. And the structure continues as follows in the picture. Next. When it comes to the SGD algorithm, this is considered only the one random point while changing weights, while gradient descent, which considers the whole training data. Logistic regression by default uses gradient descent, and as such, it would be better to use SGD classifiers on larger data sets. And this is also the fitting algorithm that we use for the optimal coefficients of the linear classifiers by updating the model's parameters using the gradient of the loss function. And next, he will observe the results in the Jupyter notebook. Here we are training the data set with two types. We are using the Titanic data set, which consists of valuable information about the passengers who sailed on the Titanic, including details like the gender, age, social, economic status, and survival outcome. And the main mission in this application is to check whether the passengers are survived or not in this journey. Here we are importing the different libraries and also the algorithms like logistic regression, SGD classifier, decision tree, and matplot, pandas, numpy as usual. Next. Can you please scroll down?
Just a moment, it's running.
Okay. Here we can say because of huge data, we have classified the data set into two types. One is we have named them as the trained data, and one is the test data. When it comes to the data description, here we can see all the columns like passenger ID, survived ID, name, age, everything. When it comes to the data pre-processing, here we can see the shape of it. And then to get each column's information, such as its data types and the number of non-null entries, here we can see the result of it, like float, int, object. When it comes to the descriptive statistical summary, like count, mean, SGD, minimum, like that. And next, to check the count and percentage of null values in the columns, here we can see the result. And by the above analysis, here we have found the few features that are missing two values, which can easily be filled to deal with the age feature, like age and sex. Here we have taken the survived and non-survived thing. When it comes, like here we have splitted the data like female and male. Here we are describing the survived status and non-survived status of the age. You can see that men have high probability of survival when they are between these ages. When it comes to the P class and the survived class, this is the graph that is shown here. Here we can see that the P class is contributing to a person's chance of survival, especially if the person is in class 1. According to this plot, it confirms that the contribution of the person chance of survival, especially if the person is in class 1, is high. These are the graphs that we can see, like P class till 4. And these all plots confirms our assumption that P class 1, but we can also spot a high probability that a person in P class 3 is high. And to get the information of the test data set, here we can see it. By inspecting the above output, we can identify the data set that contains both non-numeric columns like name, ticket, cabin, embarked, etc. When it comes to creating a new feature that's called hash cabin, from the data set, we can see that some passengers have cabin codes. It will be labeled as true, otherwise it will be labeled as false. And also creating a new feature is alone. Here we can see the code, and we also imputed the embarked function, and also we use the values here, and we are also dropping the unnecessary columns. And then we are splitting the data back. Before we proceed the filling missing values, imputing the age. By verifying the output of trained data, we can see that all columns are numeric. And when it comes to the information of data, here we can see it. When it comes to the feature selection, it is the heat map and is a color-coded matrix that shows the correlation quotients between all pairs of features in our data set. And this correlation quotient represents the data in different columns. Here we can see the picture with all the results, and we can also see the different colors that are describing its features. And from this heat map, we can observe the columns, the P class, fair, ease, alone, embarked, and has cabin. That shows a stronger correlation with our target variable survived, which is in the second row and second column. When it comes to the importing label encoder, here we can see the result. And next, the standardization, which will be followed by Frank.
Okay, thank you, Shravya. Thank you for that. Standardization is nothing but it is another scaling method we can use in these algorithms, and This is centered around mean with the unit standard deviation. This means that the mean becomes zero. So we use this feature as a standardization. Coming to the regularization refers to techniques used to calibrate machine learning models. But in this function, we overfit the underfitting. So that's why we can't do the regularization process in particular data set. So here is the no imbalance data in our data set. So and our model is also performing well. So we can't use this regularization here. And now I'm continuing the building machine learning models. Before coming to the machine learning models, I need to explain about the leftover models. The random forest or the random forest decision is a supervised learning algorithm. It can have the classification, regression, and other tasks like that. It is basically a set of decision tree from randomly selected and the train the data set. It collects from various different decision trees, deciding the final prediction and also trees of various subsets given data set to the improved predictive data set. And this is working on random forest algorithm, how the tree is going to work. The first we train the data set and training the data set couple of times, and decision will take that from decision one to three. We finally overlap those all things and voting the predictions. And coming to the support vector missions, the final algorithm we are using in our application. Support vector SVM is supervised machine learning. We can have this regression through problems as well as it's best suited to the classification. And the main object of the SVM algorithm is to find out the optimal hyperplane and n-dimensional space of the data points. And SVM can be used for a variety of tasks such as classifications, spam detection, handwriting identification, Gini expressions. These all main included in that. And this is how does SVM works actually. Suppose we have data set has two classifications. We want to classify the new data point, either blue or green like that, shown in the figure like this. This is positive hyperparameter and maximum match. The support vector is combining the both and give the best hyperlink. And that's all from the end. And now I will show the execution of our running results of machine learning models in our application. Yes, building machine learning models in our application. We will train the several machine learning and comparing the results of the all machine learning algorithms here. So we provide labels and the testing. We need to use the predictions on the training set. So this is the static gradient SGD. Now I'm running the SGD algorithm and the logistic regression algorithm. This is just a warning and k-nearest neighbor algorithm I'm run and the random forest algorithm just now explained about this, and the naive Bayes algorithm we used here, and the linear support vector SVM, and also the decision tree, the final one. So here we see the final one. Now we run the final output. Here we can see the random forest decision. These all are accuracy like 98 and 98 all performing well. And as we can see, the random forest classifier goes on the first place. The comparing the whole algorithms, we can see the SGD and SVM perform less because of some issues. But we used here one more feature called hyperparameter tuning. This is a hyperparameter tuning. If you use this, it takes couple of hours to run the program application. So that's why we didn't using. But if you run the hyperparameter tuning more, you will get the best accuracy here, like above 90 like that. And this is a k-fold cross validation we did in our project, like for bonus points we accepting. So we did this for our persons, and I'm running this also getting the standard deviation mean scores also. For the future importance, another great quantity is random forest is make many ways to measure the relative importance and also scikit-learn measures the futures and also how much tree nodes that use for the reduce injury and also across all the things. And this is a import subplot where our data set age and the features. That's all, and we also included the confusion matrix for our best understanding purpose. These errors and D-type integers from the scikit-learn. We use the confusion matrix also in this project. I mean the application, and also we use the precision recall things. Our model predicted 81% at the time passenger server correctly precision the call tells. Precision recall curve for each the random forest is nothing but the graph you can see there, the scikit-learn matrix and the AUC curve. The curve shows the positive rate and the false positive rate and true positive rate TPRs. These are the final accuracy and the ROAC score of our 96 getting better results from that. That's all from our end. Thank you all. Thank you guys.